The information I gave you on this one is sufficient for the volume. I threw the surface area in later because I thought this would be good just to kind of make it a dual problem. But this surface area for this pyramid is not impossible, but very difficult, to say the least, to get this guy's surface area. So 10C, don't worry about the surface area. Just do the volume. Okay. For a pyramid, to get the surface area, I need to know the slant height. And the base is this irregular triangle that makes the surface areas of the lateral sides very difficult. It's not impossible. I could make it a bonus or something, but is everybody with me? So if you tried 10C, had trouble with the surface area, that is to be expected. If you had no trouble with it, show me that. See that. That'd be awesome. Student becomes the teacher. So again, today's wide open, just like the last review day. You can do whatever you guys want to focus on. Everybody's got a practice test, yes. If you want to talk about quiz corrections, homework problems, problems from the practice test, it's completely up to you. So if nobody asks any questions, I'm just going to stand here like this. Oh, yes.
Can you do 1 and 2 on the practice test, please?
I don't know, let's see. Do. Bum, 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 bum. Hey. Oh yeah, okay. So, you guys, this is partially my fault, partially all of education's fault. When I say hexagon, you guys normally think about the shape that's in 3A, yes?
Yeah.
But what kind of hexagon is 3A? The shape that's in 3A?
Hexagon.
No, I'm sorry. Just the hexagon piece. Chop off the other part. What kind of hexagon is that?
2D.
Regular. Why is that a regular hexagon? All the side lengths seem to be congruent, and all the angles seem to be congruent. So this is what comes to your mind understandably. If you ask a student to draw a triangle, what kind of triangle do you think most people will draw? Equilateral. It's kind of like the most pleasing to us. It's the standard shape. Bam. But what does it take to be a hexagon? What's the only thing it takes to be a hexagon? 6 sides. And they have to be straight sides. Yes? Line segments. So look at number 1 again. What kind of shape is it? Well, I mean, I gave the answer away, but why is it a hexagon?
That's 6 sides.
Yeah, it's got 6 sides. Do you guys see that? So the repeated shape is an L. It's the shape of an L, but it's on nobody's forehead. So but it is a hexagon because it's a 6-sided it's a 6-sided polygon. Is that okay? Not the standard idealized hexagon you have in your head, but it's still 6-sided. So it's a hexagon. So then what's the appropriate name for this shape, this 3-dimensional shape? It's a repeated hexagon. Hexagonal prism, yes. I like it. That's a trippy word. Do you guys see what I'm saying? 3A is kind of like your standard, the word regular now makes more sense. It's your regular hexagonal prism, yes. It's the hexagon you all have in mind when I say the word hexagon. 1 is also a hexagonal prism, poor little dude. But I like that problem because we get so used to, and again, it's partially my fault, it's the book's fault. We just throw so many regular polygons at you. You start to think that's what they must look like. But you know that a quadrilateral does not have to be a rectangle. But we work more with quadrilaterals. Okay, I'll shut up. anything else you guys want to talk about, or is this going to be very short?
Number 2.
Two. Oh yeah, sorry.
Yeah, that's good.
Oh, can somebody define, I really hate asking you on a test or a quiz to define something, so that means I can ask you right now. Can somebody define polyhedron? A polygon is made up of line segments. So polyhedron, what are the faces of a polyhedron supposed to be? Polygon. And it's gotta be a closed, three-dimensional space, yes? You guys kinda with me? So is 2B, is that cool? That looks like somebody started to make, do you guys remember a truncated cube where you chop up and then they just got tired when they chopped up one? So 2B, people might get freaked out because it doesn't look like something we're used to, but every face is a polygon and it's closed. And of course 2A, what's the problem with 2A, poor little 2A? Yeah, it's got a curved top, so the top is not a polygonal surface, so it can't be a polyhedron, poor little guy. It could be a mailbox. Okay, you guys, is that right? So the basic building blocks of polyhedrons are things that they themselves have to be created from line segments. So therefore, no part of a polyhedron can truly be rounded. If you give a polyhedron enough faces, you can start to approximate something that looks round, like a soccer ball. If you look at a soccer ball, well, it's sort of curved. Each one is a little bit curved, so it is sort of round, but yeah. Is that okay? All right, so that one we've talked about quite a bit. So this should really jump out at you that this is no good. It's no good, it's no good. How are you guys doing with like a number 3? I like 3C because we hadn't really seen that as far as I remember. We hadn't really seen that. Did anybody get what 3C is? Oh yeah, you can do this too, Jeff. It's a little better. 3C, we hadn't really seen that kind of net before. But can you imagine if you, by the way, one reason you guys have your kits is because then at home, you can just do shit. So you could have laid this out from the parts you have in your kit and folded that shit up and saw what it looked like. So what kind of shape will this be if I fold up all the sides? 3C. Oh yeah, it's 2 3s, I'm sorry. 3C is the shape. I want to show off my counting ability. I just like the number 3 a lot. 3C, if I fold up the first three. Pyramid. What kind of pyramid? Hexagonal pyramid. But you know, again, the difficult thing with problems like number 3 are not everybody has good spatial reasoning in their head. Not everybody has good spatial reasoning. It's just something that we seem to either be born with. We can develop it over our life, but if you never do anything that develops that, you're not going to have it. So for some students, number 3 kind of problem could be very difficult. So then you help them develop it. How? By using the parts that you guys get to play with. The more they play with that, the more they can develop in their head. They can kind of see them doing it. If you never play with the shit, you can't see yourself in your head doing it. Alright. 3B, of course, is a robot head. That's what I see. But, you know, after you fold that sucker off, what's it going to make?
Cylinder.
Cylinder, yeah. And of course, you would fold it up like this so that these can just go whoop, yeah, or the other way. Whoop. Okay. Now, what is it about the second 3 and number 4 that you guys have to memorize? What is it you're supposed to come in with knowing?
King Henry died drinking chocolate milk.
King Henry died, I think, what's with King Henry died? Units? King Henry died and I can't get away from unilateral. But in the middle, I think it was you that brought it up, yes? In the middle, it could either be meters, and that's why Monday. Grams, and that's why I said giggling, or liters, and that's why I said laughing. But King Henry died Monday. Ugh. Keep talking about. So the middle could be whatever unit you're talking about. You guys with me? So all of the prefixes around it, whatever that middle thing is, are multiples of that. 10 times this way, 1/10 this way, blah, blah, blah. So that's what you have to memorize. I am going to give you the same thing I've given you before. Those same little conversion blocks. Remember that I gave you on the last quiz, I believe it was? Yes? Okay. You will have that.
For 4B, does that like change anything?
Hell yeah.
That confuses me.
Probably, here's the best way to do that problem. In fact, let's start off with this. Let me do a problem that's leading up to that. And you're like, do whatever you're going to do, man. Okay. So, for example, what if I said 17 centimeters equals how many inches? How would you set that up? I'll get it started. I'm going to put 17 here. What goes where here? Don't worry about the numbers yet. Yes, why? So they'll kill each other. So it's kind of like, I always think of this as being very subversive. You're taking the centimeters and you're replacing it. Yes? Invasion of the Body Snatchers type. Does anyone happen to remember, and again, I'm going to give this to you. Does anyone remember how many centimeters in an inch? 2.54. I love that. Somebody.
Really close.
There's a joke about Canadians. Give them an inch and they'll take 2.54 centimeters. So 2.54 centimeters. Obviously not a really well-known joke, but for math people that really hits. What's that going to be, Jeff? It's going to be about, what would that be, 3.4, so like 6.8? 6.8? Does that sound right? I don't know, somebody doing that for me? No? You're all going to go? Let's just go with whatever this guy did and said.
6.69, yeah.
Damn it. I suck. Okay, now, whoever asked the question, was it Euclid? You're like, great, Jeff, that's great. So that's easy. Thanks, man. But here's the trick. If I give you square centimeters, how many centimeters are literally in this expression? How do you get centimeters squared? What do you multiply by itself to get centimeters squared? How do you get x squared? What do you multiply to get x squared? X times x. What do you multiply to get centimeters squared? Centimeters, don't worry about the number. Centimeters times centimeters, yes? So here's something you can do. You can rewrite this as 9 centimeter, Jeff. You can rewrite this as 9 centimeters. Watch what that does for you. I have to kill centimeter how many times? Twice. So I'm going to kill it once, and then I'm going to kill it again. And what do I want to replace each time with? Yes. Square inches. So I'm sorry. Each time I replace with inches, and then what am I going to end up with, of course? Square inches, yeah. So then what does each one of these get? 2.541, 2.541. I'm going to show you an alternate way to do this, but does that way by itself make sense? To me, I like to start with this one because you can see each thing needs to be killed. So you must apply that idea twice. If it was cubed, you apply it 3 times. And now I just take 9 divided by that thing twice. Yes? 1.3 something. I did this and I can't remember. I don't know where the answer key went. There it is. There it is. Oh boy, I was off. No, I just can't read my own writing. I think it's 1.4 roughly. Yeah. Is that what I said? Yeah, 1.395. Okay. That I looked at. I looked at that. Now, the other way to do this, is everybody kind of cool with that? So again, if I had cubic, you would put centimeter, 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 and then you'd kill it 3 times. I like that because it's very in your face. It's very familiar to this. I just had to put it once because I only had one. The other way to do this is to put on the bottom 2.54 centimeters in 1 inch and square each one. Now that gets tricky. But do you see how it's just 1 inch times 1 inch is 1 square inch? 2.54 times 2.54 is 2.54 squared. So mathematically, the math don't give a shit. It's the same thing. But visually, the first way might make a little more sense. Either way you do it, you come out with the same answer. Okay, maybe. Yes. Yes.
Are we gonna have it on the test or should we not?
Yeah, I'll give you that formula.
Okay, and also, can we go over?
Or those formulas, both ways. Go ahead.
Can we go over letter E?
Ooh, yeah.
4E.
Okay, so what do you guys think is the first step in 4E? Yeah, 5 foot 3 inches. And you have to remember, so the reason I can't deal with that directly very easily is because that's 5 feet plus 3 inches. Now I could break it up into 2 problems and change feet to centimeters in it, but why do that to yourself? What's another way to say 5 feet 3 inches? 63 inches, yes. Because 5 feet is 60 inches, is that cool? So that's the other way I can talk about how tall somebody is. In fact, when you're younger, you normally talk about the whole number of inches. When you get older, you get taller. You can break it down into feet and inches. Okay. So 5 feet 3 inches is 63 inches. And then it becomes basically the reverse of what we just did. Is that cool? Because now where does inches go? On the bottom, so they'll kill each other. And then I just put, is everybody really cool with this? That step is easy, yes? You just gotta put it diagonal so it does end up, and now you know where to put the 2.54. Where do I put the 2.54? On the top, because I need what I put to be true. 1 inch is 2.54 centimeters. The fundamental question when you're converting is, do I multiply right now or do I divide right now? And this grid just kind of answers that question for us if we analyze the units. Now, if you're somebody who doesn't really need the grid, you still have to show me what the hell you're doing. Don't just throw a number down and I'm like, where'd that go? Yes.
So like on the quiz, you had one kind of like this, but you didn't have to change from metric to how whatever I forgot the word for ours. But I made like a box for it, and like let's say it was 9 centimeters squared to center, and it's like just.
Oh, you made a little visual.
Yeah.
So it'd be 3 by 3.
Yeah.
And then you can convert each,
or 9 by 1 or whatever.
Or 9, oh yeah, whatever gets you there.
Yeah.
And then you can convert each of those.
That's fine.
Yeah.
Okay.
Yeah, there are other ways to do these besides what I'm showing you. In general, as long as you show me what you're doing. Always. That's the key. And that's why math people who say they're teachers and they ask you to get a Scantron for something, they're not a math teacher, because the most important thing in the world is what is the student's thought process. So that's why I must see work. That's why I have a shirt that says show your work. It's everything to me. It's my whole job is to see what you're doing, see if it went wrong somewhere, pick up what went right, and help you with the parts that went wrong. And I can't do any of that if I just see them. You know. Hey. So like really basic area formulas, like area of a triangle.
So that list you gave us last time, pretty much.
Yes. Well, alright. I'm not gonna make you memorize, in fact, I think I've told you I'm not gonna make you memorize the trapezoid formula, even though you really should be. but I'm still gonna give that to you, if I give you a trapezoid problem, yes. And obviously, the more advanced surface area and volume formulas, you with me?
Yes.
Yes. Okay. Yeah. And again, if there's ever a problem with the test and you're like, I don't remember the formula, and you didn't give it to me, just go up and ask me. I could have forgotten to put it on there. I'm like, oh shit, that's right. You know what I mean? Yeah. And by the way, there could potentially be for this test. Those of you who took me last semester are used to this. There could be a little couple stations up here. So for prom, you come up, do something, and then I check it off. You guys with me? So up here, there could be like stuff, and you have to come up with one problem and do something for me real quick. I'll check it off if you get it right. All right, good enough. Any stuff we've played with could come into play on this test. Sure. Some of you guys are like give me side eye. I love it. Oh yes, 7. Perfect. If there's one problem I thought on here, I was definitely going to go over a question. This is one of them. So the whole point of an area formula for a triangle, this is not the standard way to put the triangle. Can you guys rotate your paper so it looks more standard? You know what I mean? Does that make sense to me saying that? If I just say that, I want to see what you guys think. Is there a way to rotate this so the triangle looks more what you would call standard? When you rotate it, what's your base now? Huh? Because I want to know. Oh, I'm sorry. I couldn't stop. All right. This looks more normal, yes? And the area for this is pretty straightforward. Pretend like this is truly perpendicular here. Obviously it didn't quite work, but give me some creative license here. So what's the height of the triangle if I look at it like this? X, and what's the base? So if I look at it like this, what's the area of it? 1/2. I think I heard it. Y times X, okay. But the way I gave it to you in the first place is still valid. What is the base, the way that it's sitting, the way I gave it to you? W. And what's the height? Z. So it's another way to get the area of this triangle. One half W times Z. And of course, there would be a third way, but I didn't give you what you need to know for this. I would have to give you this guy's height. I didn't give that one. Are you guys at all with me? So you gotta be this kind of thing. This little tiny problem shows you how you have to be careful. When you create a problem and a student solves it a way you didn't expect, you have to stop and say, were they still applying the right idea? Did they just do it in a way I didn't think about? That happens so much in my job, it's insane. And sometimes I'm like, holy shit, I never thought to look at it like that. I'm gonna start to teach it like that. I have stolen things from my students. For damn sure. And then they're like, where's my royalty for shut kill? Just like comedy, man. If you don't put it out there first, I'm gonna steal it, put it out there. Is that okay? You guys see that? So officially any triangle I'm given, I can make any of the 3 sides my base. And then I just have to have a way to get what the height is in that orientation. And I only gave you 2 ways to get the height, so there's only 2 ways you can get this area. Did you actually have to get the area? No, I didn't give you the. Just write the expression. Yeah. When you first read that problem, it's a little bit tricky, I'm sure. No? Yes? I try to make it tricky. So. Okay. What do you have to be careful with on a problem like number 8? Yeah, always, whenever I give you any shape or whatever, it's got units on something, make sure all the units are the same. On number 8, I didn't tell you which way to go, so I don't care. So I could take a answer in cubic centimeters or cubic inches. It's up to you. If I were you, there's only 1 centimeter, I would change that to inches. But it's totally up to you. Does it make sense? Yes? Yes. Say again? Oh, if I turn it like this, the height is X and the base is Y. Yeah. And I'm sorry, this drawing didn't really get perfect, but that is, I did put a little box there. So this is perpendicular. It's supposed to be. Oh, yeah. And this. Sure. Sure.
Sorry,
Huh?
can I get one too?
Oh, practice test? Yeah. Bum, bum, bum. Do I have something else for you? Yes. Sure. Okay. So, the fact that I'm going to give you a lot of the formulas we talked about is a good thing. You still have to understand the parts of the formula and what they mean. Yes? So when you see a big ass A in a surface area or volume formula, what does that mean? Like the volume of a pyramid is 1/3 big ass A times H. Yes, area of what? The base. Kick ass. And in some shapes, the base could be a few different things. So, okay, when you see L, what does that mean? And surface area and volume. Could mean 2 different things, but could mean slant height, yes? Or if it's just a rectangle, then it's like let's see. Yeah, these were all very straightforward. This one again, well, no, this one I didn't do that. Haha. I was nice on this one. This is the one I'm going to give you that little box that has the information about. Do I have an example of it? I think I do. Yeah. This little box here. Now, real quick, does it make sense that if I put here Kool-Aid, or if I put here mercury, or if I put there, some other liquid, those numbers would definitely change? Why?
It's heavier. It's like with milk and water. They
Yeah.
They need to be way different usually because milk is a little more dense. So it's
There it is. That's the key word, density. You're my density. So this only works for pure water. If I have water that has impurities in it, that could also affect this. But you guys kind of with me? Just to let you know, that's why I say specifically water. If it's some other liquid, you don't know. You need more information. Yeah.
Can we go over number 5 in relation to that?
Oh yeah. All right. So what's the very first thing I have to do here? In fact, I'm asking for kilograms. Yes. So let's see. If I look at my chart, what leads to kilograms of water? What side unit of length leads to kilograms? You can do it.
DN?
Yes, good. Decimeters, right? So if I change my sides to be decimeters, or my units for my shape to be decimeters, my answer in cubic decimeters is exactly the same as if I end up with 11 cubic decimeters. That's 11 kilograms of water. Or water. Yes, ma'am?
Yeah, I would just use the King Henry for that.
No, you don't. All right, so watch. You ready? Oh, for this here, yeah. I'm sorry.
Just
To change these into decimeters?
Yeah.
Yes. So King Henry did what?
Fry, melted, James chocolate.
And then you could put next to each one, it's little, because we're talking about meters. And I want to go from meters to decimeters, so I just have to go one this way. So what's the length going to be of the base? 6 decimeters. And what's the height of the pyramid going to be? 30 decimeters. And now you find the volume, and since you change those to decimeters to begin with, your answer will just be automatically converted to kilograms.
Okay,
Because you chose the one that goes right there.
thank you.
You are very welcome. Yes.
I have a question on the homework, 13.3, number 18.
Uh, 18. Oh. Ooh, yeah. Frustum. Ooh, can you see this? What's it asking for? If the cup is sliced open and flattened, the sides of the cup have the shape shown next. Use the dimensions given to calculate the number of square meters of paper used in the construction of 10,000 of these. I love it. So basically, you rip the sucker open, the sides have this, and you know the dimensions of the top and bottom, yes? This is supposed to be a cup. So the top should be open, I would say. So what am I concerned about? You're thinking about, how do I construct these cups? So to make one cup, you need this much for the side, and then you can see how much you need for the bottom. Hopefully you understand you don't also put on the top, because then you can't hold shit in it. All right, so did they help me by splaying that out at all? Let me see. So this is not a cone because it doesn't come to a point at the bottom. Yes? You with me? This does come to a point at the bottom if I extend it, yes? Okay, maybe. Could you get the area? I'm trying to figure out the area of this. Yes? Okay. So how could I get the area of this? What's wrong with that shape? What's kind of wrong with it? It's got a curvy part to it. Yeah. Okay, that's all you have to say. It's got a curvy part to it. Yes? Alright, so then let's see. I'm going through my head as far as how much we actually know in here. We haven't talked about, here's the angle. I don't remember talking about, let me see. I'm very curious now. There is a way to do this problem, but it involves something I don't think we've talked about. Because I don't think did we talk about, okay, so I talk about the same thing in several classes. Did we talk about, no, we haven't talked about arc length and the area of a sector of a circle, for example. Did we talk about that? That sounds familiar, but no, not in here. All right, that is my dilemma. Area, sectors, yeah, we definitely didn't talk about that. Okay, so how are you gonna figure this out? Let's see. So we know this is 11.5. We know this is 26 centimeters. This is not truly a triangle because this side is curvy. And the closest example I've got is when I use an actual cone, it opens up to be this. But can you see if I chopped off, and again, this is my book, so I can do this. If I chop this off, don't I end up with basically the shape they have? If I chop that piece off, yes? So if you look at this like a full cone minus this little cone. Do you see that? Okay. So here is a full cone, and you can see how that kind of leads to the formula they have. So if you apply that same formula to this full thing, and then apply it to this little piece and subtract the two. So this is kind of like, I can't remember if I think I've said this kind of thing, a cookie cutter problem, where you have a whole thing and then you slice out a part of it. They gave us the angle, which makes me like, we definitely didn't talk about the, there's another way to do this, but we can do it this way instead. Let me think about why they gave us the angle. The angle can't come into play for us because we didn't learn that. That's kind of driving me crazy. I'll be right. Yeah, they don't talk about angle here. So here, real quick. So pi r squared is the circle. And that would be the bottom. And of course, did they give me r? No, so that's its own little problem that's easy. Thank the gods. And then the rest of the shape gives me this piece. 1/2 2 pi r times L, where r is the radius of the circle. We know that. And L is this slant length, which we know for the whole thing. We know the whole thing, yes, and we know the part that I want to cut out. Is that giving you enough to kind of like go on? Okay. I don't want to do the whole thing, but that problem is a little tricky because when I looked at it first, I had a whole way to do it, and I'm like, no, we don't know that. We don't know the area of a sector of a circle. And then, of course, whatever you get for one, multiply by 10,000, because you want to construct 10,000 of these. Why? I don't know. You're the one doing it. Yeah, maybe. By the way, I'm very curious. If I were in this class and I got to that problem and they tell me up here, this is the frustum of a right circular cone, I would immediately go to Google and say, what the hell is a frustum? And what is its surface area? Right? But I hope you don't do it, because now you see how they do it. And then you can do it afterwards and go, did I get this right? By the way, real quick question. Have I talked much about ChatGPT at all with you guys? A little bit? ChatGPT is absolutely stupid. It is stupid. I'm just getting more into it, and the amount of things it can do. I asked it to create a quiz for one of the higher level classes with an answer to, and it did it. And then I said, can you create an animation showing this? And it did it. I was like, what the hell? What the hell? We're there. We are in the future. Holy shit. Oh yeah, I think I told you. I gave you too much information. I had to call me that voice. Alright. Anything else from homework or the practice test or the quiz or generally? Yes, I do. I'll go ahead and give it to everybody. By the way, on this kind of problem here, well, you can draw on your little robot, but in this kind of problem here, when it's just a King Henry problem, if you write this down and you kind of show me moving around a little bit, that's all the work I need to see for just pure metric conversions. They're supposed to be easy. There shouldn't be a ton of work you have to show me. And in case you weren't here earlier, I think everybody here was here. Oof. This one was much harder than I thought because I didn't really create this problem to be a surface area problem in the first place. I didn't really give you enough information to do it, but the volume you can definitely do. And by the way, do you guys remember kites and their weird little area formula? Anybody? It's 1/2 the product of the two diagonals, yes. And real quick, in that kite I gave you, and in any kite I could possibly give you, do you guys see 4 triangles? And they're all right triangles. Wouldn't the area of this triangle be 1/2 10 times 6? This triangle right here, yes? And then this one will be 1/2 2 times 6, yes? And if you put all those together, you get the same answer. So that's why if there's an established formula, it might not be the only way to do it. Plus 48 plus 16, yeah, it doesn't. Sorry, good.
4D and E don't have an answer for the rest of the
Where are we at?
4D and E.
Oh shit! Alright, let's do this. I just obviously skipped them over. So what is the formula for going, does anyone remember, and I'm going to give this to you, but the one going from Celsius to Fahrenheit, it's not too bad.
Something plus 32.
Yeah, something plus 32. So let's do this. We're going to do 4D and 4E together, because I forgot. So I'm still averaging about 97 on keys. Let's see. So it's be 9/5 times negative 20 plus 32. How do I do 9/5 times negative 20? If you didn't have a calculator. 5 goes into 20 4 times. Negative 4 times 9 is negative 36 plus 32 is negative 4. Okay. And then part E we talked about earlier. 5'3" is 63 inches. So I'm going to put inches on the bottom so I can go to centimeters. 2.54 centimeters in 1 inch. And what would that be, math boy? I don't know. 32 is 160 roughly. Let's see. 160.02. Damn it. I'll try to remember on the test to say round answers to the hundredth place where appropriate. So if your answer is 7, you don't have to be rhetorical. Put 7.00 thing 7 times. So where appropriate, round to the hundredth place. Okay. What did I do? I totally screwed that one up. So, real quick. Jesus Christ. I appreciate myself so much. I made a mistake on number 5. Just because I wanted to. Yeah, let me say. So guys, I purposefully made it. Yeah, shut up. I made a mistake on number 5. Can anyone see the mistake I made? I made kind of a big mistake, which is really making me excited. Right here, this should be square meters, which would totally make this not what I put it down as. So what I should do is I should convert everything over to decimeters like we did earlier. I don't want to say this. X equals 6. Oops, this should be 30 decimeters. X equals 6 decimeters. So then the area would be 6 decimeters squared, which would be 36. And then the volume would be 1/3 36 times 30. So I'm off by a factor of 10. I don't know if you guys see what I'm talking about. I squared 0.6. I didn't have a square here, so I just converted. I don't know if you guys really understand why that's wrong. Because if I have square meters, I can't just move once to convert it to square decimeters. I actually have to move twice. Because I have 2 meters that each have to become decimeters. So if I just convert all of my lengths first and then throw them in, I would have been fine. So this would come out to be 360. So I'm off by a factor of 10 there. This pyramid can hold a lot of water. Rookie stuff, Chuck. So the lesson to be learned there is before you do anything, you should convert all of your given lengths to where you want them to be. Because once you start squaring things, the conversions are not the same as they used to be. We all know this. If I want to convert from square inches to square centimeters, I can't just use 2.54. I've got to use 2.54 squared, right? One for each thing. So on number 8, I apparently, like I said, I chose to convert to inches. So I just changed 7 centimeters to inches. And that's what I used to get the volume. Yeah, okay. Everything else looks pretty straightforward. I'm hoping. I always feel like students don't believe me when I said I have drawn nothing. It's dependent on what you guys want to focus on. Sorry, how long ago was spring break? That was 8 weeks. Spring break was the 8-week part. So isn't that 2 weeks ago, spring break? Oh yeah, 10 week? Jesus. The semester's just so flying. Anything from the homework? Anything from the quiz? Somebody guys, I love it when somebody packs up and they're just gonna stare at me.
I feel bad leaving.
So the word chef. Any class, anytime you need to go, you can go. I'll just keep track of your name, so I know you're gonna give me an A, so. No, I'm not. If you don't give me an A, you know. The last step will be much more difficult than any step. Oh, that's
No, I get it. I look at the wrong part of the
Oh, shoot. I'll do it too. Yes.
I got in my head about this forever, where I was
Oh, this is yards. You don't need to. The minute you get that in feet, then feet can go to miles. So if you just didn't have this here, you'd be gold. Yeah. Right there, you got it. So watch this. So you got your inches. So now you're feet. And then if you don't have this here, get rid of feet, and now you're in miles. Yep. Then you should have been multiplying by seven. No, stop. It's very weird that this would be this easy. That all you need to do is make sure the units do what you wanted to do, and then fill in the numbers. It doesn't feel like it should be that easy, but
I feel like there's
there's not a.
I feel like there's like no.
Well, it does, but you can have, the answer could be 0.003. You know what I mean? It could be not a full line. So it's okay, right? We can have parts of stuff. So the answer could be less than 1 for sure.
Yeah.
Yeah.
Yeah, they look okay. Well, now we know. Oh yeah, we talked about that. Surface area, I didn't give you any information. That's why on this one it says inches. Because originally I was just gonna make these volume problems, and then I added in surface area without realizing I was gonna have enough information here, so. Yeah. So you don't have to do that one yet. I wouldn't give you a problem like that on the test, so I can beyond. Well, there is a way to do it. There is. It'll take about an inch.
And is it okay if I just use the surface area formulas from last year?
But we have, where'd you get that? Did you get that from somewhere?
Yeah.
Oh, you did what I said.
Yeah.
Okay, I appreciate that. Yes, but can you see what I was talking about? That you can find the big cone and the small cone and subtract to get the leftover?
Yeah.
Okay, as long as that makes sense, I'm okay with that. Because if I gave you a problem like that, I'm not gonna give you the formula, but like I was saying up there, if you don't do what you did, I don't quite understand you, right? You should go, what the hell's the first one? And what's the surface area? Oh, and there it is. What?
Yeah. Cause like I wrote what it was at the top, like the surface area.
Yeah,
And then
yeah.
labeled it all,
Yeah,
and then
nice.
realized I forgot to add the base of it.
Oh, yeah.
So I was like, oh wait, I didn't do
So
that.
that's gotta be, I love it. That's research, that's awesome.
Not great.
Oh, I didn't bring my spreadsheet with me.
Oh, no,
Did I not? No, that was a quiz we took last time. You could email me or something if you don't wanna.
And I'll see you Wednesday.
Okay,
I mean,
I'll try to see if I can remember to bring my little
okay.
thumb drive
If
with.
not, I'll just email.
Okay,
Thank you.
sure.
But I didn't